Hi everyone, I'm Sonia, and in this video, Amayr and I will be presenting our explanation of AnimateDiff, which is the paper that we've chosen for our term project in CS89. The full title of the paper is AnimateDiff: Animate your personalized text-image diffusion models without specific tuning. So the problem that the paper is trying to address is that there are many advanced text-image diffusion models that allow personalization and essentially produce high-quality images at an affordable cost from text inputs. However, adding motion to these existing models in order to generate animations remains a challenge. The paper presents AnimateDiff as a solution. AnimateDiff is a text-to-video method to enhance an existing text-image model by adding a motion modeling module that can be directly integrated and produce smooth and visually appealing animations without requiring specific tuning. Here are some examples of GIFs that we generated using AnimateDiff. In terms of data representation, the input is a 5D video tensor. This is then reshaped to merge spatial dimensions into the batch axis, and then it's divided along the temporal axis, which results in a sequence of vectors, each representing a frame with shape, batch size, by height, by width, by channels. In terms of workflow, the motion module is first initialized and appended to the frozen stable diffusion text image base model. It's then trained on videos to acquire a motion prior, and finally it's injected into any personalized version derived from the same stable diffusion text image base model. Going into more detail into the training of AnimateDiff, first, there are domain adapter layers that are implemented in which the domain information is fit to a separate network called domain adapter. This is to address the fact that the visual quality of publicly available video training datasets is much lower than their image counterparts. Next, the motion module actually learns general motion priors of video training datasets. And finally, in the last stage, LoRa layers are added to the motion module. LoRa stands for Low Rank Adaptation for Motion, and it's a method designed to fine-tune the module efficiently by modifying only a small part of the model using a limited number of example videos. These example videos demonstrate new motions and allow the module to adapt it to new motion patterns.
In terms of quantitative results, AnimateDiff was rigorously evaluated using comprehensive clip metrics and user study scores, focusing on three areas of text alignment, domain fidelity, and animation smoothness. So starting off with the user study, researchers aim to effectively evaluate the effectiveness of different animation methods on personalized text-image models. Essentially, the participants reviewed animations from three distinct approaches, assessing them on text alignment, domain accuracy, and motion smoothness. These results were then aggregated into an average user ranking, in which higher scores indicate better performance. And then on the clip metric, this metric was essentially employed to assess the technical alignment of animations with the original images and prompts. It focused on the same three metrics, but providing a computational perspective. And the higher clip scores denote more precise and fluid animations. So the results were found that in the user study, AnimateDiff scores highest in domain and smoothness aspects, indicating better perceived quality and fluidity in its animations. And then on the other end, in the clip metric, the AnimateDiff shows the highest domain similarity and smoothness scores, validating the technical effectiveness of the animations and staying true to the original content and achieving smooth transitions. And in reviewing the qualitative results, researchers utilized unique trigger words to evaluate AnimateDiff against other diverse T2I models from Civitai. They essentially showcase AnimateDiff's versatility through 8 different animations, each adeptly handling different themes and styles. And the integration of motion LoRa into hand shot type adjustments allowed the researchers to inject dynamic elements that made the animations more engaging. And they also used motion LoRa's innovative composition to use creative weight merging to allow for more complex and sophisticated animations, showcasing its capabilities. So these are the qualitative results in comparison with AnimateDiff to text to video 0 and tuna video. As you can see, AnimateDiff provides superior quality in its animations, notably in maintaining domain fidelity and smooth transitions. And in conclusion, AnimateDiff revolutionizes personalized T2I animations with a scalable plug-and-play motion module. Utilizing its transformer architecture, it can effectively capture dynamic motion priors, expanding its use from traditional media to interactive content. Additionally, this module balances computational efficiency with high-quality output, enhancing the realism and flexibility of animations. Thank you.